object of 4 kilograms thrown upward from ground at an angle of 53 degrees to the horizontal, the initial speed of 100 meters per second. It suddenly explodes into three fragments 10 seconds later. One fragment of mass 500 grams uh, uh, moves downwards at the speed of 100 meters per second. The second one, 1500 grams, having speed of 200 meters per second, moves east just after the explosion. So we have to find the speed of the third fragment immediately after the explosion. What is the change in the kinetic energy of the object during the collision? Okay, so it is shown like this: 100 meter per second. This is at 53 degrees. After 10 seconds, first we have to find the speed. So if we make the components, then this is 100 cosine of 53 degrees, and vertical components is 100 sine of 53 degrees. The horizontal component is not going to change, right? Because there is no horizontal acceleration. Only the vertical component will change. So after 10 seconds, what is its speed? After 10 seconds, its horizontal speed is going to be 100 cosine of 53 degrees, which is not going to change since there is no acceleration. Uh, vertical velocity is going to be, I'm going to use first equation of motion, that is v naught plus at. So v naught, if we take the upward direction as positive, so 100 sine of 53, acceleration is minus 9.8 and t is 10. Okay, so 100 times sine of 53 minus 98 is going to be minus 18.14 meter per second. What is the meaning of having a minus value? It means that its direction is downwards because upward was taken as positive. Totally fine. So before the collision, the situation looks like this. This is 100 cosine of 53 degrees initial horizontal velocity, and this is 18.14 initial vertical velocity. This is 4 kilogram. Let's try to find the value of 100 cosine of 53 as well, which is 60.18. 60.18, right? Okay, so this is before the collision. After the collision, uh, a 500 gram piece moves downwards at 100 meter per second. So 100 meter per second. This is 100 meter per second. It moves down, and over here we have. Right, so this is 100 meter per second downwards. This is of zero point 0.5 kilogram. It's always a good idea to write in SI units. And we have a 1.5 kilogram object moving east. East is over here, so that is at 200. That is 1.5 kilograms. And the other one, we have to find that where is that moving. So let's say, what is the remaining mass, by the way? 1.5 and zero point 0.5 is 2. Out of 4, 2 is already taken, so rest 2 kilograms remaining. So let's say it has v1 velocity over on the horizontal or east side and v2 towards the south side. This is of 2 kilogram. And now comes the point where we conserve the momentum. So since the momentum is conserved, we're going to do it in two directions. The first is the horizontal direction. The initial momentum towards the horizontal direction is 4 times 60.16. The final momentum towards the horizontal direction is 1.5 times 200 plus 2v1. Since it is conserved, so we are going to say that 1.5 times 200 plus 2v1 should be equal to 4 times 60.18. What is 1.5 times 200? That's 300, right? That's 300 plus 2v1, and that is equal to 4 times 60.18, which is 240.72. If we subtract 300 both the sides, so we have a minus of 59.28. So the value of v1 over here comes out as, definitely it comes out as negative. So that's negative 29.64, and negative means that it is vertically down. All right, vertically, sorry, over on the left, because it assumed as right, but its negative means over on the left. And likewise, we are going to conserve the vertical momentum as well. Initial momentum is going to be 4 times 18.14, and the final momentum is going to be 0.5 times 100 plus 2 times v2. So if we're going to conserve this momentum, so that's going to be zero point 0.5 times 100 plus 2v2 is equal to 4 times 18.14. So this is coming as 50.2 v2 is equal to 18.14 times 4, which is coming as 72.56. If we subtract 50 both sides and divide both sides by 2, the value of V2 comes out as 11.28. And since we are supposed to find its final velocity, and these are the components, so its final velocity is going to be, since these are at 90 degree, so final is going to be 11.28 square plus 29.64 square. 0.28 square plus 29.64 square, and the square root of this value comes out as 31.71 meter per second. That is the final velocity. All right. Okay. Then they are asking there was a change in the kinetic energy of the object during the collision. Okay. So for the change in the object, we have to find the initial kinetic energy. So the initial kinetic energy is half m is 4, and v square. What is v square? So we have its two components of the velocity over here, uh, uh, which is one is this and the other one is this. Actually, it's better to write these two. So their net velocity is going to be the square root of its to go back up 18.14 and 60.18. Okay, 18.14 and 60.18, and we have to square this, right? Because the kinetic energy is half mv square, so that's going to come out as 18.14 square plus 60.18 square times 2. So the initial kinetic energy is going to be 7901.38 joules, and the final kinetic energy is going to be half m is zero point 0.5, then its speed is 100, so that's zero point 0.5 times 100 square plus half 1.5 times its velocity is 200, so that's 200 square plus half 2 times its velocity is 31.71 square. So this value comes out as 100 square times zero point 0.5 plus 200 square times 1.5 plus 31.71 square times 2 over 2, which is coming as 33505.52. All right, okay. So if this is the case, then so the change in the kinetic energy is going to be the final minus initial, which is 33505.52 minus 7901.38. So this value comes out as 25604.14 joules. This is the final answer. Thank you.